In 2020, China's Chang'e 5 mission returned to Earth with a sensational discovery. A previously unknown mineral was found in the lunar soil it brought back. What makes this find unique is that the mineral contains helium-3, an incredibly rare and valuable isotope. When it comes to the energy systems of the future, it may play the same role as oil did in the industrial era. And this time, the United States is not in the lead. The initiative has been overtaken by Russia and China. The two countries have already signed an agreement to build the first moon base equipped with a nuclear power plant, and the project is expected to commence very soon. Given the speed at which China builds cities on Earth, a lunar power plant no longer seems like science fiction. It's not unthinkable that one day you'll step outside at night to admire a full moon, only to find its appearance has changed. Dotted with scientific bases, research stations, and possibly even signs of military conflict unfolding right on its surface. So, get comfortable, because we're about to show you an amazing glimpse of the future. What extraordinary mineral did China discover on the moon? And why could it trigger a new race for clean energy? Why do China and Russia need a nuclear power plant on the moon? And finally, is it even possible to colonize the moon? In 2020, for the first time in 44 years since the Apollo missions, China's Chang'e 5 mission successfully delivered moon soil samples to Earth. You're looking at the very capsule from the Chang'e 5 spacecraft right after landing. Even the Chinese scientists standing nearby could not yet imagine how valuable its contents would prove to be. After 2 years of extensive research, scientists at the Beijing Research Institute of Uranium Geology discovered something completely new in the samples. A mineral previously unknown to science named Chang'e Y. Scientists managed to model its structure, a phosphate crystal elongated in an elegant columnar shape. But the true value of the discovery wasn't just its novelty. What made it extraordinary was what was found inside the crystal. That substance was helium-3, a special isotope of helium that only exists in microscopic quantities on Earth. Here, it isn't mined directly. It's so rare that the only way we obtain it is a byproduct of nuclear reactors, where it's practically collected drop by drop. But the real value of helium-3 lies in its massive energy potential. Research shows this isotope can be used in nuclear fusion, a reaction that releases tremendous amounts of energy. And unlike conventional nuclear fission, fusion using helium-3 produces virtually no dangerous radioactive waste. Imagine a powerful, clean energy source that leaves no toxic byproduct. This is why helium-3 is considered the ideal fuel for the fusion power plants of the future. But how large is this reserve of clean energy on the moon? Studies have yielded staggering results. The moon's surface could contain 1 to 3 million tons of helium-3. If we could extract all of it, estimates suggest it would be enough to power the entire Earth with clean energy for the next 10,000 years. Experts at the Lunar and Planetary Institute have already run the numbers and concluded that mining helium-3 on the moon could generate colossal profits. According to their data, a single ton of this substance could be worth $1.4 billion, about the same as 50 F-16 fighter jets. The total value of 3 million tons would amount to a staggering $4.2 quadrillion. For reference, that's 37 times more than the entire global GDP of 2024. A source of such high-value, clean energy hidden on the moon could not go unnoticed by the world's leading powers. Whichever country gains access to it first will unlock a path to enormous technological and political supremacy. So, if you're wondering how exactly we can access that energy, the Chinese government already has an answer: the first ever lunar research base. Using this base, Chinese authorities plan to launch grand missions for lunar exploration and the extraction of its valuable resources. Even now, China is forming a coalition of countries to implement this lunar project. 17 nations have already joined the initiative, including Egypt, Pakistan, Venezuela, Thailand, and South Africa. But the most unexpected participant is Russia, and not just as a regular member. With its help, China plans to build a fully functioning nuclear power plant on the moon. This may sound like science fiction, but this is the exact and very specific goal currently being pursued by scientists and engineers from both China and Russia. Of course, building a nuclear power plant on the moon is nothing like building one on Earth. You might as well try constructing one on the ocean floor. Theoretically possible, but it would require an enormous amount of resources and effort. Naturally, the first crucial stage in building a lunar base will be securing the necessary construction materials, and you'd need a whole lot of them. These may include durable polymers resistant to extreme temperatures, as well as aluminium and titanium alloys. It's hard to even imagine how much it may cost to transport all this from Earth. Think about it. In today's money, the 1969 Apollo moon landing cost the United States nearly $300 billion. And building a real lunar base today for a coalition led by China could cost even more. It would be far easier if the required materials were already on the moon. That way, there'd be no need to transport everything from Earth. And in fact, some resources are already there. But how did they get there? And can they actually be utilized? Sometimes what seems like a catastrophe becomes a source of something valuable. For billions of years, the moon has been bombarded by asteroids, giant space rocks that often carry rare and precious metals. Thanks to these continuous impacts, the lunar surface has gradually become enriched with rare substances. Iron, nickel, platinum, all of this could be right beneath the feet of future lunar settlers. In fact, there may be huge quantities of these valuable metals. Just look at the moon. Its scarred surface speaks for itself. Over billions of years, it withstood countless asteroid impacts. It's hard to even estimate how many valuable resources might be hidden in those lunar craters. Unfortunately, directly using those resources for construction is not an option yet. To extract metals in their pure form, lunar rock that contains them must be processed. This requires specialized equipment, technology, and skilled personnel. It's probable that processing lunar materials will only become viable in the future once there's a full-scale industrial infrastructure on the moon, including machinery capable of operating locally. So, for now, China has virtually no choice but to deliver construction materials from Earth. Once those materials arrive, the actual construction process can commence, which will also be far from simple. Most likely, the base will be built without direct human involvement. All construction work performed by autonomous robots, at least until the moment of the nuclear power plant installation. While robots can assemble pre-delivered components, the more sensitive and critical operations will likely require astronauts. Additionally, operating a nuclear power plant in harsh conditions of vacuum, extreme temperatures, and total isolation presents a completely new level of technological challenge. One of the biggest challenges we face may be uranium, the standard fuel for nuclear reactors. Transporting it from Earth would be extremely expensive, inefficient, and unsustainable in the long term. That's why helium-3 once again comes to the forefront of our calculations. It's a lightweight, stable, and nearly ideal fuel for nuclear fusion, abundantly available on the moon. A power plant running on helium-3 would not only be able to supply the base with electricity, but practically become its beating heart. Powering equipment, running life support systems, and most importantly, supplying energy to the heavy machinery required to extract rare and precious metals. That's right, even though these metals can't yet be used for the lunar base construction, they can be mined and transported back to Earth, where valuable elements will be extracted from the lunar soil under familiar conditions. The primary targets will be especially valuable metals like platinum and gold to justify the high cost of transportation. In addition, other elements may be mined as well, including scandium, yttrium, and other rare earth metals used in manufacturing engines, high-strength glass, ceramics, electronics, and radar systems. It's very likely that helium-3 will also be transported to Earth. All of this has the potential to drastically reshape the global economic balance. One thing's almost certain. The first country to establish lunar resource extraction will become a superpower with unmatched influence and dominance on the world stage. However, things are not as simple as they seem. There are a number of serious obstacles, and the first of them is water. In the context of building and maintaining a nuclear reactor, large quantities of water are a must-have, especially for cooling the reactor. On top of that, water is going to be essential for supporting life on the lunar base, and most importantly, for rocket fuel production. And if water has to be transported from Earth, the cost of such space projects would increase significantly. But there may be a solution. Take a closer look at the Moon's South Pole, a region filled with ancient craters. But their age is not what sets them apart, it's the darkness that they harbor. Due to the fact that the Moon's axis is barely tilted, only about 1.5 degrees, sunlight travels almost parallel to its surface. As a result, the depths of certain polar craters are permanently shrouded in shadow. To say that they get little sunlight is an understatement. Some craters haven't seen sunlight for billions of years. In the animation produced by NASA, you can see how sunlight skims past the Moon's south pole. Some craters do not get exposed to a single ray of sunshine. These are known as permanently shadowed regions, PSRs, and this is precisely where water is expected to be found, and a lot of it. You might ask, how did it get there? The answer takes us back to the era of cosmic catastrophes and falling asteroids. A recent study by the Sophia Observatory, a joint project of NASA and the German Aerospace Center, found that there was ice on the surface of 2 asteroids. Normally, the presence of ice in space is associated with comets, which are essentially large chunks of ice and dust. Asteroids, on the other hand, were thought to be dry, rocky objects, but the new findings show that ice can also exist on asteroids, albeit more rarely, and only on asteroids far from the Sun. Asteroid strikes the Moon. Most of the water vaporizes within seconds. Only a tiny fraction can survive the impact, and only in the shadowed parts of craters. But at the South Pole, the situation is different. Here, the areas of permanent darkness preserve ice for millions of years. As such, it's no surprise that the Moon's South Pole is where China has planned to build its base, and the timeline announced by Beijing is impressive. Construction is expected to be completed by 2036, with a fully operational nuclear power plant in place. The first symbolic step toward this goal will be the Chang'e 8 mission, scheduled for 2028. It will mark the first time in history a Chinese astronaut lands on the Moon. In contrast to China's ambition, backed by a coalition of countries including Russia, the United States is starting to fall seriously behind. The Artemis program, which aims to return Americans to the Moon for the first time in over 50 years, has already faced multiple delays. Right now, Artemis 3 is expected to launch in 2027, but even that date is uncertain. The fate of the Gateway Station, an orbital lunar base NASA had planned to deploy, adds even more uncertainty. Its launch was also set for 2027, but after the release of the 2026 budget proposal by the Donald Trump administration, the project's future has been called into question. But in any case, the main question right now is who will land on the Moon first, and, more importantly, who will be the first to stay there long term. Regarding this, the US and China take completely different approaches. Researchers in China have already built a training facility to simulate lunar conditions, located in a real volcanic lava cave. all because in the early stages, lunar caves and tunnels are considered some of the safest places for habitation since they provide protection from radiation, solar flares, and extreme temperature fluctuations. Meanwhile, NASA is betting on surface construction with minimal costs. According to their plan, there'll be no need to transport construction materials from Earth at all. Instead, they'll send a mining robot to autonomously extract rock, accompanied by large 3D printers that can convert lunar regolith into fully formed structures. NASA has already presented their vision of what these lunar buildings would look like. Tall, barrel-shaped structures containing everything you need to sustain human life. According to specialists, these structures could last over a decade on the Moon. Their height could reach 165 feet, roughly equivalent to a 16-story building. Fascinatingly, NASA plans to use the same technology to 3D print not only buildings, but also roads that go on for miles, and launch pads stretching 330 feet across. Picture this. Astronauts land on the Moon, met with a fully equipped base, roads, and launch facilities. Meanwhile, German scientists have developed their own method for generating energy on the Moon. The most logical choice turned out to be solar panels, an ideal solution for powering future lunar settlements. But yet again, we're facing the same challenge. Delivering them from Earth would be incredibly expensive. That's why the experts took a different approach. They decided that in the future, solar panels will be manufactured directly on the Moon, using lunar dust, no less. By simulating lunar regolith, German researchers succeeded in creating a special lunar glass which can serve as material for solar cells. Most importantly, these solar panels are not only cheaper, they're also more durable, unlike Earth-based glass which darkens and loses efficiency in space over time. Due to its natural impurities, lunar glass already has a brownish tint and barely changes when exposed to radiation. Estimates suggest that manufacturing solar panels on the Moon could reduce transportation costs by up to 99%. It sounds like science fiction, and for now, this is only a theoretical plan, concrete as it may be. Meanwhile, Japan is also joining the lunar race. They're particularly interested in the aforementioned source of clean energy, helium-3. The US, China, along with Russia and now Japan, are all setting their sights on lunar resource extraction. And if you thought the Moon was large enough for everyone to share, you'd be mistaken. The situation is far more complex, even dangerous. To assume that nations will peacefully divide lunar resources among themselves is naive, especially when we're talking about a substance that could potentially power humanity for the next 10,000 years. The main issue is that almost every country is aiming for the same location, the Moon's South Pole. According to scientists, this region may contain the highest concentrations of helium-3 as well as large deposits of water ice. In reality, every major power wants to be the first to land and establish a presence in one specific region of the Moon, desired for its abundance of resources. But the question is, do they even have the right to do so? As of now, no international agreement regulates who can extract resources from the Moon or how they might do it. Formally, the Moon is similar to Antarctica, where any nation can choose a location and build a base, but only for scientific purposes. A similar principle may be applied to the Moon. Whoever lands first, sets up equipment, and declares an area of responsibility will effectively control that territory. But it's hard to believe this will happen without conflict. Let's face it, events unfolding on the Moon will only superficially relate to science. In reality, the main focus will be resource extraction on an industrial scale. And unless an international treaty is established to regulate lunar territory and mining rights, things could escalate from disputes to real political or even military confrontations. It's unlikely that one superpower would calmly watch another exploit Moon resources in its most valuable region, gaining a major strategic advantage in the process. Joseph Silk, an astrophysicist at Johns Hopkins University and the Paris Institute of Astrophysics, believes that lunar mining could mirror the times of the Wild West, a rush to grab the largest share. This scenario could be the beginning of a military conflict, not just on Earth, but possibly on the Moon itself. However, we cannot claim with certainty that this will happen. It's simply one of the most likely scenarios. based on the current state of global affairs. Resource extraction on the Moon truly has the potential to reshape the global balance of power, help solve environmental challenges, and become a catalyst for new technologies. But that's only possible if lunar mining is conducted responsibly for the benefit of all humanity, which is all we hope for. Still, colonizing the Moon may prove to be far more difficult and risky than we currently imagine, if only because we still don't fully understand all the processes occurring on its surface. Our observations of the Moon only reinforce that uncertainty. On November 16th, 2022, the Orion spacecraft and Space Launch System rocket was launched from NASA's Kennedy Space Center in Florida. The SLS rocket system stands almost 100 meters tall, weighs 2.6 million kilograms, and can develop 4 million kilograms of thrust at maximum load. After facing setbacks due to unsuccessful tests and the impact of Hurricane Ian, the rocket launch finally took place to the delight of thousands of researchers and scientists. Orion approached the Moon at a distance of 130 kilometers, circled it, and headed back towards Earth. Throughout the mission, which covered an impressive distance of 2.2 million kilometers, the spacecraft systems were rigorously tested in order to evaluate their performance in space conditions and their impact on human astronauts. 3 dummies were positioned in the cockpit of the Orion spacecraft, each fitted with sensors to monitor the effects of radiation, acceleration, and vibration during the flight. A Snoopy plush toy equipped with a zero-G indicator also went along for the ride around the Moon. The spaceship was also equipped with CubeSats, miniature satellites each the size of a large shoebox weighing about 14 kilograms. These sophisticated instruments monitored the spacecraft engines, analyzed space weather, and took high-resolution images of Earth and the Moon. Unlike the Apollo lunar mission, Artemis benefits from a multitude of advanced computing devices and sophisticated robotics. Advanced technology is now ready to put astronauts on the Moon, and those astronauts, with the help of machines, will build a permanent outpost. NASA plans to construct a base on the Moon with a gateway station in orbit. NASA is already gearing up for the challenges of creating livable conditions for astronauts at the Moon base. The Exposed Route on Orbit test system, utilizing aeroponic and hydroponic systems, is growing vegetables in conditions similar to those on the Moon. Additionally, 3D printers are being tested to manufacture necessary items on site. For instance, in the case of medical emergencies, astronauts can use bio-ink to produce personalized patches made from their own cells, enabling swift healing of injuries. Still, some experts believe the creation of a permanent lunar base may be in vain, as robots are gradually replacing human astronauts. Robotic rovers have already been successfully exploring celestial bodies beyond Earth, conducting research, collecting samples, and performing complex tasks. They operate without interruption, food, or shelter, and can even avoid hazards like steep craters and massive sand dunes. NASA's Perseverance rover is a prime example of the capabilities of robotic systems. Equipped with a 7-foot-long manipulator arm holding a range of scientific instruments and tools, it's able to collect rock samples, examine Martian rocks, and identify chemical elements with the help of its planetary instrument for X-ray lithochemistry. Its 23 high-quality cameras can take pictures of collected samples as it travels around Mars without any human commands. NASA has even planned to install a radio telescope on the back side of the Moon to explore space without interference from Earth. Experts believe that robots can handle such a project without human assistance. These systems can perform complex tasks that would be dangerous or impossible for humans and operate indefinitely without any need for life support. Robots offer several benefits for space exploration, including their ability to withstand the rigors of long-distance travel. Despite the fact that it only takes approximately 3 days to reach the Moon with current technology, it's still critical to ensure that machines do not sustain damage during the journey. Advancements in technology are also helping to reduce travel time, as demonstrated by NASA's New Horizons Pluto mission. The The rocket accelerated to a speed of approximately 16.26 kilometers per second and arrived at the Moon in just 8 hours and 35 minutes. Mars, on the other hand, is significantly farther away from Earth than the Moon, and it can take at least 6 months for a spacecraft to reach it. During the journey, astronauts will have to cope with the challenges of being in a confined space with no gravity and exposure to dangerous cosmic radiation. Space travel comes with an incredible amount of risk to astronauts, and tragedies can sometimes occur, like what happened in 1986 when the Challenger shuttle exploded 73 seconds after liftoff, and in 2003 the Space Shuttle Columbia disintegrated on re-entry into Earth's atmosphere over the Pacific Ocean. In both instances, crew members tragically lost their lives. Technology has advanced quickly in the last few decades, and space travel is much safer now, but that doesn't mean there still isn't a risk. Robotic explorers would be much safer than using human astronauts on a mission. At the same time, using robots would also safeguard extraterrestrial worlds from the potential dangers posed by human astronauts. There's a risk that humans could contaminate subterranean bodies of water that may exist on Mars, Europa, and Enceladus with microbes. These bodies of water could potentially host alien life forms that would have no natural defenses against human infections. NASA recognizes all the benefits of using robots for space exploration and is already working on developments in this direction. The autonomous pop-up flat-folding Explorer robot was inspired by origami products to create this lightweight, two-wheeled adventurer. The A-Puffer is a highly versatile robot that's capable of operating in tight and narrow spaces. It can adjust its shape by straightening, tilting, and folding as needed, making it an essential tool for exploring various types of crevices and confined areas. And this is the Brewy Floating Rover, specifically designed for use in icy environments and has the ability to maneuver acrobatically while swimming in water. It can even operate upside down on the underside of an icy surface while collecting data and capturing images. There are also hedgehog-shaped robots that have been developed to explore asteroids and comets with uneven surfaces and weak gravity. These robots move by bouncing and tumbling and can even escape from deep craters by surging upward like a tornado. Additionally, if they happen to land upside down, it's not a problem, as the robots can flip themselves over without issue. NASA is also working on the development of humanoid electric R5 Valkyrie robots, equipped with numerous cameras, sensors, motors, and 2 computers that enable them to imitate human movements and navigate their environment independently. It's possible that robots will become the primary explorers of outer space in the near future, while humans work on creating even more advanced and intelligent machines. According to British astronomer Professor Martin Rees, within the next few decades, robotic exploration of the lunar and Martian surfaces will become almost completely autonomous, as human presence will not offer significant advantages but will require costly infrastructure deployment. The use of robots in space missions is significantly cheaper compared to manned missions. The Artemis project is estimated to cost about $35 billion, a cost that's unlikely to generate much enthusiasm among taxpayers. But the exploration of distant worlds like Mars is still perceived as a significant breakthrough that could justify the cost of manned missions, which could reportedly cost up to $1 trillion. This cost is incomparable to the mere $2.7 billion cost of the Perseverance rover or the $38 million cost of the lunar roving vehicle. As a result, Martin Rees believes that the Artemis mission can mark the end of manned missions rather than the beginning of a new era like Apollo. Private companies are now joining space exploration efforts, which could ease financing problems for scientific missions. Private companies can also develop space tourism, which would cater to many people's dreams of visiting the Moon or Mars. Elon Musk, the CEO of SpaceX, has already promised to sell tickets to his Martian ship, Starship, for $100,000, and people are already showing interest in buying them. As we look towards the future of space exploration, it's clear that both robots and humans have important roles to play. Whether it's sending advanced rovers to explore distant planets or launching brave astronauts on daring missions, the wonders of space are still waiting to be discovered. So, buckle up, space enthusiasts, because we've got a whole universe of stunning discoveries to uncover and share with you. Make sure to click the super thank you button if you enjoyed the video, and stay tuned here by subscribing for more exciting news on space exploration. Thanks for watching.